forget that. All your hard work will soon pay off. That is a little generic, but it's not a bad fortune. I think the music's at a good volume. I hope so. Okay. Okay, we got it now. 42 seconds, not bad. No, I'm too stuck in my ways. I don't want to ever use flags. I don't think. I'm not. I would have to put in a lot of effort to get the muscle memory to use flags, and I just don't really want to do that. Cause like it would take a lot of work to have better times using flags, even if they are theoretically faster. It's not that bad. I mean, the issue is deciding when it's a good time to use flags. Like, or like you don't want to always flag every single bomb, and so you have to figure out like which bombs are worth flagging, I guess. Just use them everywhere? I feel like that's a waste of time. Okay, you know what? Let's do another one. This time we'll flag every single bomb. The fastest runs don't use them efficiently. Huh. Okay. But yeah, I will also chord. I hate this. I hate this. Ah, this is disgusting. Should I chord it? Should I do chord only? That's kind of what this turned into. Maybe that's what I need to learn how to do this. Oh, close enough. $66. That's not like a huge dip, but I don't know. Chord only for real. I should try it. I think that's how I would have to learn for sure, and then I can, once I get good with chording, I can start to mix them. I don't know how to go back. My last one was like 43 seconds. Go back. Oh, I guess that works. 3 BV. I don't know what any of these mean. Oh. 20 seconds is a lot, though. I don't know. What was the... Okay, so 62 versus 65. Never mind. Without using flags. Huh. Interesting. Okay. I don't know. I'm kind of set in my ways, but the right answer is to, you know, use chords sometimes. Oh, okay. I guess we're doing another. All right, we'll even do chord only, just for you. Well, okay. Unless I don't have an option. Can you use chords to fail? Like, will they ever click on a mine for you? I wonder. Dude, I could be chording a lot more efficiently if I just click on the right squares. Uh, no. Dude, I hate this. I have to relearn. How to play this stupid game. I hate learning new things. Okay. A69. If you miss a flag, you can fail with chord. Okay. And faster than you still. It's skirt. I, I usually on my phone, I do massive ones, and I feel like it's a lot easier to tap with my thumbs than it is to use a mouse. See, on my phone, it's a 30 by 24. What's the evil? I'm not gonna count this. With 160 mines. That says 130. I don't know. Ghive. My girlfriend came home and dragged me into the bedroom and told me to take off her shirt, bra, dress, stockings, and panties. Then she said, if I ever catch you wearing them again, I'm leaving. Ugh. If I had a nickel for every time that happened. Hey, Ghive. Gonna try to beat it? Please do. Smile. Tomorrow's another day. Eh. Yeah, exactly, skirt. It is for losers. Okay. Yeah, my first one with no chording was 40 seconds. 42. All right, so the plan for today is, I guess, more puzzles, unless we get a question from chat. So I still don't feel like doing hard math, to be honest, so... Okay, I think we're on 29. Oops, I don't have my screenshot thing up. Hey, Murrow. Why am I doo-doo? It's just the way I was born, skirt. I can't help it. I've tried everything to not be doo-doo. I've asked doctors, but they just told me that I'm screwed. I'm doo-doo for life. 55? I mean, that's a good time, too. Comparison is the thief of joy. In a museum, I saw an old clock with Roman numerals instead of the familiar 4. There's an old-fashioned. Oh, really? Huh. Is that actually like a real thing that they used to write 4s like that? Cracks had formed on the face, divided into 4 parts. Picture shows unequal sums of the numbers in each part. I didn't know the 4 tick marks was like ever used. That's seems like a lot to write. I guess that's why we have Ivy instead. Cracks formed in the face divided into 4 parts. The picture shows unequal sums. The numbers in each part ranging from 17 to 21. Can I change one crack, leaving the others untouched, so that the sum of numbers in each of the 4 parts is 20? I guess the first step is to figure out what these sums are. 12. Why is it also... I guess the old-fashioned 4... Oh! Because the crack goes through the 4. Interesting. The crack as changed does not have to run through the center of the clock. That's a big hint. Okay, so 12, 13, 15, 18, 20. Uh, 2. Actually, the music needs to be turned down slightly. Uh, 7, 13, 20. Oh, they... Never mind, I'm dumb. I didn't see these numbers. So kind of, it says, wait, cracks. Can I change one crack? I mean, is this one crack or is this one crack? I assume that that's 2 cracks. Uh, Does not have to run through the center of the clock. Can I do something weird like that? I guess I probably could. That's not the right answer for itself, though. So it does seem like the way, like, we probably need to change this crack, I would assume, because... How else could we possibly do this? Oh, yeah, you're probably right, Arad. Maybe we need to do this. That's 20. That's 8, 9, 17 plus 1. That's not enough. Oh, yeah, yeah. Because I would need to be 40. And it's not. Um... Well, what about this crack instead? 11, 12. That's an 8? Yeah, okay. Yeah. That must be it. Okay. I can't imagine there's another solution for this problem. So I think I like that. Okay, the wondrous clock. Watchmaker was telephoned urgently to make a house call to replace the broken hands of a clock. He was sick, so he sent his apprentice. The apprentice was thorough. When he finished inspecting the clock, it was dark. As soon as work was done, he hurriedly attached new hands to the clock by his pocket watch. 6 o'clock's the big hand of the 12, little hand of the 6. The apprentice returned, but soon the telephone rang. He picked up the receiver only to hear the client's angry voice. You didn't do the job right. The clock shows the wrong time. Surprised, he hurried back to the client's house. And the clock not showing much past 8. He handed his watch to the client, saying, check the time, please. Your clock is not off even by 1 second. The client had to agree. Early the next morning, the client telephoned to say the clock hands apparently gone berserk, moving around the clock at will. The apprentice rushed over. The clock showed a little past 7. Checking his watch, the apprentice got angry. You're making fun of me that the clock shows the right time. He figured out what was going on. This is weird. Got to read this through again. So when he finished the clock, it was dark when he finished inspecting it. Apprentice returned. Soon the phone rang. Didn't do the job right. The clock shows the wrong time. What? Moving around the clock at will. What the hell? What is... Is the client just stupid? Is that the problem? It needs salt? It definitely needs salt. A little... Not much past 8 and a little past 7. One's at night, one's in the morning. I have no clue. I think the client's just stupid. I think except the moving hands could be explained by the pocket watch being out of time. I mean, maybe? You can't call clients stupid? Watch me, skirt. I bet you wish you could do that all the time. You always ask if they're okay. Depending on your tone, that could be even worse. Like, are are you okay? That's kind of like a funny question because it can like the implication can change a lot depending on how you ask it. With the big hand the seconds clock. Oh, that's a thought. Hey, Suhas. Soup to you too. Big hand at 12, the little hand at 6. I kind of just want to look at the answer. I feel like it's going to be something stupid. Like, depending on, like, the clock hands are supposed to move around at will, just at a certain speed. That's also true, Arad. Like, how do you know it's the wrong time? Hmm. So, okay, maybe I should read... Make house call to replace the broken hands of a clock. Only the hands were broken, not the actual mechanism of the clock. So who urgently needs a clock fixed? When is that ever urgent? Hurley attached new hands, set the clock by his pocket watch. It was dark. Hmm. No, I have no clue. I just want to look at the answer. I really don't know with this one. This is a weird puzzle. Maybe the client's a drug addict, and it's just high. The apprentice mixed up the clock hand so the minute hand was short and the hour hand was long. Then the apprentice returned to the client. It was about 2 hours and 10 minutes after he set the clock at 6. The long hand moved only from 12 to a little past 2. Short hand made 2 full circles in an additional 10 minutes. Oh, that's what they're after. They should have said the exact time though. Like, I I was thinking that like the only thing it could be is that the apprentice switched up the hands. That seems like a really stupid mistake to make. Um, but they simply did not say what time it was. I guess that's true, noob. Being dark makes it harder. The next day around 7:05 a.m., he came a second time. Lucky him. 13 hours, 5 minutes after he set the clock for 6. The long hand, acting as the hour hand, covered 13 hours to reach 1. I I kind of call malarkey on this puzzle. They're using the exact time in the answer, but they did not say the exact time in the puzzle or in the question. I guess, is there only one time? Is this like a magic? Is there something special about the time we should have been able to figure out? I mean, okay, I guess 8:10 sounds good. Moreau, sleep well. Thank you for hanging out. So 8:10. I'm trying. I made 2 full circles. I need to actually like draw this out because I don't understand what's happening. So wait, does it probably even say the apprentice mixed up the clock hands? I don't think it says that. So the big hand at 12. The little hand at 6. One, two. And so the issue is this is the hour hand. And so after 2 hours goes by, we end up at 2, which is 10 minutes. And then after 10, okay. That's why this is a magic time. But we have also said the same, okay. So I guess once per hour, you get a magic time that happens to look right, is the point. Like this puzzle would have also worked if it was about 7:05. Hmm. Yeah, if it was like 8, if the time was 8 in any other minute, this would not have worked. And they did say it like not much past 8. So I guess I take back my malarkey accusation. But I don't know. This puzzle doesn't feel very satisfying. So I feel like the answer was obvious, but explaining it was difficult. Because like that's the only thing that like could have gone wrong, I guess. I probably should have thought more about it, but oh well. Okay, this one might. I think I like this one more than a clock one. I gotta get the other piece in a second. Okay, 3 in a row. On a table, arrange 9 buttons in a 3x3 square. When 2 or more buttons are in a straight line, we call it a row. Okay. So rows A, B, and C, D have 3 buttons, and E, F has 2. That's one definition for row, I guess. How many 3 and 2 button rows are there? Okay, so I guess 3 button rows. We have these 3 rows. these 3 rows. So that's 6. And these 3 rows on the diagonals. So 8? I don't think there's any other straight lines that work. So let's look for 2 buttons. There's like the diamond hands. That's 4. And then each of these corners, I guess, has 2. So that's 8. So 12? I'm not missing any. Oh, no, I'm not. Yeah, I think it's everything. Now remove 3 buttons. Arrange remaining 6 buttons in 3 rows so that each row contains 3 buttons. Ignore the subsidiary. Okay. Remove 3 buttons. Arrange the remaining 6 buttons in 3 rows. Oh my god, I hate this. What is this definition of row, though? 6 buttons in 3 rows so that each row contains 3 buttons. Oh my god. I was just thinking about a pyramid. I probably should have drawn that out. I was trying to work out in my head if this meets the criteria. So that each row contains 3 buttons. Well, this is a row of 2 buttons here, though. Like, I think these are problems, right? We're ignoring. Wait. No, I feel like I don't understand the question. It says to ignore subsidiary 2-row buttons this time. But they all need to have 3 buttons, so I don't know what we're ignoring. In 3 rows. Because I guess a triangle also has this issue too, doesn't it? Oh, I mean, instead of equilateral, do we want a right triangle? Bam, bam, bam. Well, I guess there's that, though, and there's that. Hmm. And I don't know what it means to have 6 buttons in 3 rows for this definition of row. Like, I guess this is 3 rows. Hmm. Yeah, I don't understand the wording of this question. I feel like it's got to be one of these triangles, if not both. But I don't know what a subsidiary to row button means. Or subsidiary to button row. I think I said that backwards. Let's look at the answer again. 31. You got the first part right. 8 and 12. X'd out buttons are removed. Wait, okay, so the equilateral triangle was apparently correct. I don't, like, understand why we get to ignore those two button rows. What's up with C? Exit buttons are removed. The dotted line circle moves slightly to the right as the arrow shows. This is weirdly asymmetric. This one also, I can find two button rows in this one too. I don't know how they're distinguishing what two button rows are okay and which ones aren't. Do I know what's happening in India? I guess not. No, Suez. And Chickpay. Integration at a high school level? 45? I mean, that's really close though. Okay, so Chickpay, what math class are you in right now? Oh, yeah, Suez, I wouldn't know about that. Like so I want to like high school could be a lot of different types of math, and I just want to make sure that I like understand where you're at, Chick Bay. Let us start your BSc in physics. You want to know grade 12 integration? Okay, but like, do you know what a derivative is? You don't need to know it, but um, it helps. And I'll explain it too, but in case you ever want like an offline explanation, this is my favorite website for calculus things, Paul's online notes. They have a whole section on integration. You do, but it isn't that clear. Okay, that's fine. Oh, sorry if there's a joke in there that I don't get to us. I just that seemed kind of like a political thing to me that I didn't want to get involved in. Um, that's what I thought. I thought you were talking about something political. It's going all right. How about you? Okay, so integration. It's a good example of a function to use here. Let's just take a parabola, y equals x squared. It's good to hear. So integration is fundamentally defined as the area under the curve of a function. So I'm taking y equals x squared as my example, and let's say we want to find the area between x equals 1 and x equals 2. It's like this area here between the curve and the x-axis. And that's what an integral actually gives you. And we would write this notationally as integral, like this kind of stretched out s symbol from 1 to 2 of x squared dx. And I'll explain what the dx part is in particular in a minute. But this is just like, yeah, to understand the dx, we need to get into the actual definition of an integral. So this is like, this notation doesn't mean anything on its own unless we define it in terms of math that we already know. Yeah, so we do use dx for differentiation, like dy dx is the derivative of y with respect to x. This is just kind of a dx on its own. So dy dx, you can think of it as, so if you remember the limit definition of a derivative, there's two different ones. I'm not sure which one you've seen, but I'll use this one. F of x minus f minus a over x minus a. You can think of this top part as like a dy and the bottom part as a dx. It just means a very small change in y or a very small change in x. And so integration is going to involve very small changes in x. And we'll see why like later on. But it like this dx is the same as this dx. It's kind of like, it's more of an idea than a concrete like interval of x, but it is related to just like some very small interval or a change. So yeah, so let's say, okay, so yeah, let's get into the actual definition of an integral. So when you're learning about the limit definition of a derivative, which hopefully you've learned about it, you can take the derivative of a function at a point. And so let's say we're interested in the derivative at this point here. We'll just call it x equals 4. Why not? What you would do is think about the tangent line, and like we really want the slope of that tangent line there. But we could get approximations for the derivative by looking at a point out here and making a secant line and finding that slope. And what this limit does is it brings this point here closer and closer to the point we're actually interested in, and it gives us the slope of the tangent that we actually want. I hope I'm not going too fast there, but that's what the limit definition of derivative does. And I'm talking about that because integrals also have a limit definition, and it's a similar sort of idea. Like you take an approximation and you make it exact is the similar idea. So coming back up to this thing up here, I'll draw a zoomed in version of it. Didn't get why we take a point A. A is just whatever point you're interested in. And usually we could keep it generic because we're interested in the derivative at every point. Find something you understand? Awesome. Yeah. Oh, yeah, Karamsham, I'm sorry. I don't know anything about that, and I really don't want to get into politics. Yeah, A is just at any point that we want to know the derivative at, and usually we want to know at every point, so we can just leave it as a variable. So yeah, coming back to my integration example with x squared, we're going to find the area between x equals 1 and x equals 2. You're getting more confused? Okay, Yeah, so I guess for now, just don't worry about the x equals a thing. It's not too important for learning integration, at least. If you want, we can talk about that more later, though. The thing I was just trying to convey with talking about derivatives is, it's pretty common in like the proofs part of calculus to you can create a proof by taking an approximation and making it exact. Um, so if we wanted to approximate the area under the curve here, what we can do is we can split this thing up into rectangles because we know how to calculate the area of a rectangle. We don't necessarily, we don't know how to calculate yet the area of some curvy shape here like this, but yeah, Karamsham, I'm sorry to hear that you got hurt, but again, I really don't want to talk about political stuff. Um, so we can break this thing up into a bunch of rectangles. So for now, I'll just do maybe 3 rectangles. Um, and so theoretically, we could calculate the area of each of these rectangles and add them all up, and that's an approximation. I guess this would be 4/3 and 5/3. And so each of these rectangles has width 1/3. And the height we could calculate because we know it's x squared. So the height of that rectangle is 1 because this is x equals 1. The height of the second rectangle is 4/3 squared, whatever that is. And the height of the last rectangle is 5/3 squared. And so it's not too important to get the actual number here, although I guess we could. We could say that the area from 1 to 2 of x squared dx is about, what is it? 1/3 times 1 plus 1/3 times 4/3 squared. I guess that's technically a 1 squared. Plus 1/3 times 5/3 squared. RimWorld? I've heard of RimWorld. I never played it though. And so if you want, you could like calculate that out, and you'd have an approximation for the area underneath the curve of x squared from 1 to 2. But again, like this is I'm trying to help you hopefully understand what's happening. Like I don't care what this approximation is, like what the actual number is. I just care that it is a good approximation, or at least it this is like the idea of how we can get a good approximation. Dr. L. My wife burned the bacon and got really upset. I said, you should embrace your mistakes. She walked over and hugged me. That's a good one. Okay, so I hope I haven't confused you too much so far, Chick Bay. Hey, no name. At a high level, like what I'm trying to say here is if you want the area under the curve, you can approximate it by breaking it up into rectangles. And so here I broke it up into 3 rectangles. Oh, so that is a good thing to understand here. So I figured out what the x values are for each of the rectangles. I mean, I feel like I didn't even draw it big enough. So remember, this is x equals 1 at the start, x equals 2 at the end. And then I split up into 3 different rectangles. And so we know that this function up here is x squared, and the heights of the rectangle are determined by the height of the function. So this first rectangle, I just plugged in x equals 1 because this is where the first rectangle ends up here, into x squared. No name, yeah, I can have a look at it after this question. And then I figured out this point here in terms of x is 4/3 because we're splitting it up into like three pieces, and the next one is 5/3. And so I took x equals 4/3 and I plugged it into the function x squared, and that gave me this height right here. Same thing with 5/3. And so this is arbitrary. I could have split up into 2 rectangles. I could have split up into 100 rectangles. I just kind of chose to split it into 3 examples, or into 3 rectangles. Okay. Maybe it's better just split up into 2 rectangles then. One, two. Euphoic or euphoic. I can try them, but I'm explaining this question about integration to Chickbay, and then No Name potentially has a question, and then you would be up next. And No Name, Chickbay just asked to explain integration to a high schooler, basically. So I'm trying to just introduce them to integration. Okay, so if, I'll split them into 2 rectangles instead, and maybe it'll be a little bit more clear. So, if I want 2 rectangles, my first rectangle will be here, and it'll go halfway through. And so this first rectangle will end at 3/2, because that's halfway between 1 and 2. And the second rectangle will just be whatever is left over. So hopefully you know where the 3/2 comes from. That's our x value. The height of the rectangle, specifically of this second rectangle, is determined by the value of the function x squared at this 3/2 point. So with this approximation, this first rectangle is the same, just has a different width. So it'll be 1/2 times 1 squared. That'll be plus 1/2 times 3/2 squared. Enderglow, for tan of tan inverse, there's sometimes some tricky stuff that can happen, but I think that should just be 132, because tan and tan inverse undo each other. Oh wait, there's probably a trick in there. Sorry, I need to get to your question after I get to other people's questions. PvPs had difficulty understanding when we end up numbers A and B and the solutions. The formulas are too weird. Yeah, those can be weird. Two denominators basically. It's just what we happen to get. So 3/2 is just the x value for this second rectangle. And the function plug into is x squared. If I was trying to approximate the area under sine of x, and let's say I was doing it from 0 to pi over 2, and again, I'll do just two rectangles. Okay, yeah, I guess if I do two rectangles here, sorry, this is just a little bit weird. I'm gonna do pi over 4 to 3 pi over 4, just to take this middle part. I'll have one rectangle that goes here, halfway between them is pi over 2, and then I'll have a second rectangle that goes here, kind of overshoots. And so, in this case, the widths are still, well, I guess the width of these intervals are pi over 2. Dx. Sorry, it's not still pi over 2, but the width of these intervals are pi over 2, or sorry, pi over 4. And then the height is, the first height is sine of pi over 4, plus the width, pi over 4, times the height, sine of pi over 2. And so I'm showing this other example because this first part is the width of the rectangle, the second part is the height, and I'm trying to show a different example where the height of the rectangle is determined by the value of the function. So at first it was x squared in this example, so we were squaring everything. I forgot the squared there, sorry. In this example, we're doing with sine x, so the heights are determined by sine of the x values. India midnight setting electrostatic, drinking coffee, came to you, felt classic, keep it up. Thank you, Doubt. Good luck with your studying. Taking pre-calc 2 this quarter? Oh, nice. So yeah, Endergo, they can sometimes trick you with inverse trig functions. Normally they kind of cancel each other out, though. Swap, any idea how to deal with BAFK log? No, I never heard of that. I don't know what that is. What did you figure out, not Chris? How to be a quack in Q? I don't know, Skirt. I was told that I would never be a quack by a really mean person, so I don't know if I can answer that. Maybe I did something? I don't think so. I'm pretty sure I'm innocent. So yeah, Chickbait, I don't know if this helps you see where I'm getting these heights from, but it comes, like, we know the rectangle has to do with this point here. And so the x value of that point is pi over 4, and the y value is sine of pi over 4. You gotta sleep? Okay, no worries. Thank you for trying, but yeah, sleep is important. Hey, Visai. I don't stream every day. I don't really have much of a schedule. If I am streaming math, it's normally around this time though. I normally stream like recently. It's just been like twice a week though. I like to stream more, but I just don't have the energy. Okay, so um yeah, if you want to read more, you Puzzle Line Notes is a great um resource. What do I do? I just graduated with a master's in applied math, and I'm applying to jobs right now. Okay, so let me figure out who's asking questions here. So, No Name wants to know how to calculate the Fourier coefficients in the heat equation. If you have a specific example, please do tell me. Um, I'll have to find an example then. Thank you, Dr. L. Who else is asking a question? You might need to remind me. Oh yeah, you Foic something about functions if they're still here. And I think that's everyone, but please speak up if I missed you. Echo, you think you might have passed function analysis? Hell yeah. Congrats. And congrats again on the good graph theory grade. Hopefully you get another good one on functional analysis. FNHD, what I'm working on off stream, job applications and projects that would support job applications. It's all getting posted to my GitHub, which there's a link to it below my stream somewhere. But I was just doing like data analysis on disparities in cancer based on sex and race. That turned into like a 15-page paper. So I tried my best today. First, you got a nosebleed in the last 20 minutes? Oh no. During my PDEs final, I had like a minor nosebleed. I just kind of, it was only like a little bit, and I was afraid that I was gonna have to like ask to use a bathroom or something. I think I just kind of like wiped it, and then I just didn't touch anything with that hand. Poor boy almost died during the exam. Let's give him 3 sympathy points. Yeah. Um. Okay, so let me find an example for the heat equation. I think Paul has a section on PDEs. I never looked at it though. Oh, you have a heat equation with a... Okay. Ugh. Okay, you know what? This is probably exactly um what you're looking for, No Name. Zach, thank you so much for the raid. Welcome in, people. I hope the I I potentially got rated. I was about to say I hope that the E&M stuff went well. What I'm looking at right now is No Name in the YouTube chat asked how to calculate the Fourier coefficients when you're solving the heat equation. potential in you understanding my puns. There is. Came in with the wild bitches rate, $8 The BN coefficient, you want to know how to find those. Yeah, exactly. As Brett School says, we use inner products. I did cloud, yeah. I just made it even shorter than it was before, like 2 days ago. You can just remember it as a formula, to be honest. Oh yeah, it's this formula right here. That's the short answer to your question. It's just a formula. My beard is officially longer than the hair on my head, for sure. F of x is your initial condition. It's u of x comma 0. Thank you, FNHT. Long as we generate orthonormal basis for the Hilbert space, right? And make it look so easy, not talking about math, talking about life. Oh god, Dr. L, I don't have anything about life like figured out. Math is easy. If you catch me saying math is easy, I think someone's taken over my body. No name, you are not dumb. It took me so long to figure out why this works, or why this formula is the way that it is. It's a really clever thing that you do. Am I good at physics? I'm okay at like E and M, and I'm a little less okay at mechanics. Like it's really a trick that you're using to calculate these coefficients. As Brett School says, you're taking advantage of the orthogonality of sine and cosine. Where does Paul actually give the Fourier series? Wait, what? What is non-homogeneous stuff? I don't care about that. Qatar Santani, am I discussing higher mathematics? Yeah, this is a type of math called partial differential equations. It's pretty deep in there. So not something you typically learn about unless you're like a math or physics student and you're pretty advanced in your degree. Isn't this, where's the cosines, Paul? Isn't this only giving you odd solutions? Right, okay, you're only talking about Fourier sine. God, okay, this is my first time reading Paul's PDE section. I don't know if I like how he's talking about this. Okay, let me catch up with chat. They're non-homogeneous Laplace. Oh yeah, just like you can have a non-homogeneous ordinary differential equation, you can have non-homogeneous PDEs. I don't know very much about them. For like the simpler ones, I should say, like Laplace's equation, maybe the heat equation, you can still get solution formulas for non-homogeneous ones, maybe? Am I making stuff up? For Laplace equation, you can. That's Poisson's equation. I don't know about the heat equation. Here's finished integral and differential calculus is something mind-boggling. Oh yeah, so honestly, you're not that far away from understanding this though, Qatar. Or I hope I'm saying that right. Qatar. Hey, Yashu. This is like multivariable differential equations. How about when you find the position of electron in a hydrogen atom with probabilities? Yeah, sure. Maybe that's related to Schrodinger's equation, and that's very similar to the heat equation. If we catch you saying math is easy, I'll assume the world is being taken over by a delusionality virus. That's a safe assumption, Chris Logical. You remember when you first learned differential equations? Not Chris. Hopefully it was a good experience. Feels like just last week. Yeah, all the times, like, introductory differential equations class are normally... I'm not a fan of them. String goes over this in his MIT OCW differential equations class. Oh, cool. String is awesome. First chapter, Principle of Applied Mathematics by Keener has a pretty good explanation of it. The generalized series allows for your orthogonal set of functions to be made into an orthonormal basis. Legendre polynomials are another form of a Fourier series. Oh, cool. Yeah, in one of my numerical methods classes, we somehow related Chebyshev polynomials to Fourier cosine series. And it allows you to kind of it's an easy way of taking a uniform grid and kind of spreading it out so there's fewer points in the center of your domain and more points closer to the boundaries, which normally is the place you want more resolution anyway. So I can imagine there's other like polynomials that you could use for a similar idea. Can't believe I only found out about them last year. Where you been my whole life? Yeah. Not just solutions to the heat. Okay. Oh yeah, the wave. Oh, actually, the wave equation. Did I? I don't know if I knew that about the wave equation. It's probably something crazy. String with continuity and differentiability. Do you have any suggestions? If you're just in a regular calculus class, pause on my notes is my first suggestion. If you're talking about like analysis, I would go to like YouTube lectures. Holy crap. Pen Center 2, thank you so much for the raid pen. You're doing the analysis stuff, right? I hope that was good. So yeah, Pav, it depends what context you're setting continuity and differentiability in, but I assume you're just in a normal like calculus class. Surely Paul goes over when things are differentiable or not, right? Does Paul not do this? Wow, I don't know if Paul does this. I'm looking for like graphs asking you if like is this derivative is this function differentiable? You have to figure out whether it's continuous and whether it has a corner and whatever. I don't see questions like that though, which is a bit of a miss, a rare miss by Paul, I might say. Boys Mouse and I were using puzzle notes for something recently. I think it was Green's theorem. Yeah, just we're apping analysis. Hell yeah, Pen. Thank you again. Whenever you solve a PD via propagator, heat wave, you can feed it into Duhamel's principle, you can non-homogeneous. Oh, true, Arad. I learned about that and I forgot about it. Duhamel's principle is pretty cool because of that. Okay, yeah, Pav, maybe I can just try and figure something out on the fly here. Is there a dark mode for the notes? Oh, I don't think there is, but I can do that. Sorry, Cursological. Not bad for wave equation, I remember correctly. Some solutions benefit characteristics. Okay, fair enough. Sharia, you have a set 1, 2, 3, 5, 8, 9. Number of possible functions, A to A. Ooh, that's like an abstract algebra type of question, isn't it? I I'll put this question up on the screen. I'm gonna talk to Pav about continuity and differentiability. But this one might be an interesting question too. I don't think I can do it on my own, but I bet someone in chat would know how to do this. Current strategy is listening, hoping something sticks since it's a bit above my level. Yeah, I mean, you might glean something. Oh, it's a JE mains question? Okay. Yeah, I can't make any promises with this question. I don't have any ideas for how to do it offhand. But I can't imagine it's got to be... It can't be that bad. Yeah, Chris, also, I say like the best way to learn would be to like ask a question and try to engage, but you might be able to pick some things up just by like listening to what other people ask too. Okay, so permutation combinations, maybe Pav. Okay, so but Pav, so for your question, continuity, I'll say the intuitive definition. You can draw the function without picking up your pencil. That's all continuity is. Multiplication, I would assume, yeah. I guess I'll say continuous. Differentiable. A function that is continuous and does not have a cusp / corner. There's different terms. Okay. Sorry if I'm explaining things that you already know. I tend to assume that people just don't know anything to play it safe, but I won't emphasize that then. So for a function to be differentiable, you need to make sure it doesn't have any weird jumps. That's kind of the case that's easier to catch because like this piece you could take the derivative of, this piece you could take the derivative of, but you have this issue, right, where it jumps, where how do you define a good tangent line there? It's not really a good way to do anything. In your notes, you're showing the last topics. I don't know which last topics you mean. Like these down here? Sorry for the flashbang. Oh, okay. Well, I guess I tell me which section you want to go over because from 3.4 onward. Okay. Because this is a very different thing that you're talking about that I guess I misinterpreted what you're asking about. Let me catch up with Chad though. Like you're just asking like what these formulas mean, or like how do we get these formulas? Didn't go to 3.14. True. I familiar with the Courant min-max principle for approximating eigenvalues? Doing a direct independent study, the book I'm using doesn't do an amazing job explaining how to actually solve for an eigenvalue approximation with it. Oh yeah, distributions are different. We did cover that a little bit in my PDEs class. I'd have to look. I definitely remember hearing about min-max. I'd have to look back through my notes. Yeah, we talked about like the nodal domains, Courant, whatever he was doing. Where's the where I? Okay, yeah. Oh no, that's I was thinking of max cut problem. Min max sounds familiar too, though. I might have to Google it because. Yeah, it's annoying. I might not know that exact thing. Kind of all over the place right now. Let me. I guess keep reading through chat. What is the worst way to rely on a zombie apocalypse? Dead zombies is a great answer. If you want like actual food, I guess I would think. I mean, pet food sounds really terrible, like dog food and cat food. Yeah, I don't know. Oh yes, read that because too high level our teacher taught us the same topics. They do last long. That's true. Yeah, Papa, I'm confused on what you want to hear about now. I'm happy to talk about anything. Oh wait, I'm in the wrong thing. I'm happy to talk about any type of stuff like this, like you might want. I just don't know what to talk about. Worst would be soup. Why soup? So you're saying something about like graphs. Are you being asked like when does the limit exist, or when is a function differentiable, or okay, yeah, I appreciate that, Puff. Okay, so let's look up Courant min-max. Oh yeah, like it has been a thing through history, like eternal soups, I think they're called, or like it's a soup that you never completely eat. You just keep it on the fire constantly, and you kind of keep adding things to it, and then taking some as you eat some, and it never goes bad because you're constantly keeping it hot. Or perpetual soup or something like that. I don't know. Condition for finding eigenvalues for a real symmetric matrix. Current minimax principle is as follows. For any real symmetric matrix, A min C. Ooh, what's happening here? What's the minimum matrix? Are we talking about determinants? How do you minimize over a matrix? Well, no, it probably won't even have a determinant if it's k minus 1 by m. Oh, wait, sorry. I'm reading this backwards. It's not argument. Okay. Whatever matrix C gives you the minimum scalar value that this evaluates to. God, this is going to take me a minute to understand what this is saying. So, on the inside, it's the maximum inner product of AX with X, where the magnitude of X is 1, and C is some fixed matrix. times x equals 0. The maximum inner product you need to heat it up, you need utensils to eat them. If you're in the middle of eating it when zombies come, you have to leave it there. If you're carrying a thermos, you'd burn yourself. Make you easy prey for zombies. I mean, you can just hold the soup up to your face and drink it, like miso soup. I don't know. Mythical infinite soup, yup. Printing real metrics A, right. Reminds me not to open a soup kitchen in a zombie apocalypse. Soup would be good if you were isolated in relatively safe space. Yeah. Number theory in chapter 2 of still algebra. Numerically define some sort of length in matrix. Yeah, Max, I was misunderstanding what the min C meant. But I have seen that too for like a positive definite matrix. I think the definition could be related to something like that, if I remember right. Applying A with stretch vectors the most in the direction of the largest eigenvalue. Iteratively smaller eigenvalues diminish. Gonna run around eating soup. I'd never eaten anything while running from a zombie. I guess like a chicken drumstick might be the ideal food for that. It's one-handed. You don't need any like forks or knives or anything. Or I guess pizza by the same logic too. Just have a slice of it. Yeah, this is annoying because I haven't seen this exact thing before. It's with I bet I can understand it though. I just need to think about it for a while. Maybe we should go for a non-Wikipedia explanation though. No, I don't care what's happening there. I don't want to read it. No, not Grokpedia. Uh This is a terrible website. Maybe I do need to look back at the scary site. Speaking of soup, we got a soup right there. Ugh. Okay, now this is not helpful. Even if I try to actually understand it. This is the problem with trying to Google like grad school level math. There's way fewer resources, and the ones that are there are really difficult to read. Like, this might be one of the times that Wikipedia gives the best explanation. I did not ask the chat, but I'd rather not. Hey Leo, it's a question from Breasticles in the Twitch chat. Let me scroll. Oh my god, my Twitch chat is stuck to the bottom and I can't scroll up. It's the most annoying thing. You refresh it. Okay. The question was about the Courant min-max principle for approximating eigenvalues. Breasticles is confused on how to use it to actually calculate approximations for eigenvalues with it. Arad, it is on the other side of the world, yeah. of the internet world. Um, the vector x is an eigenvector to the corresponding eigenvalue lambda. Hmm. Actually, this paragraph looks kind of interesting. The Courant minimax principle, as well as the maximum principle, can be visualized by imagining that if the set of all vectors with magnitude 1 is a hypersphere, then the matrix A deforms the hypersphere into an ellipsoid. That makes sense. When the major axes on the intersecting hyperplane are maximized, i.e., the length of the quadratic form Q of x is maximized. That is this is the eigenvector, and its length is the eigenvalue. Oh. All other eigenvalues will be perpendicular to this. All other eigenvectors will be perpendicular to this. What is the minimizing C then? I understand that you would get your maximum like change in length when you go along your like major eigenvector that is the highest eigenvalue. But that doesn't explain where the minimum or the min over C comes from. The minimizing C is what I call dinner with my mother-in-law. I don't know what that means, actually. I'm trying to figure it out. Zombie apocalypse soup, true. Oh, yeah. If anyone understands this on the first try, they're on a different level. I did enjoy learning about this type of stuff during my PDEs class, but I can't say that I really understood it. Like, quadratic forms are something that the professor kept saying were super important, that were kind of lurking in the background. I know nothing about them. Another way is to erase the larger eigenvalues so that the kth one becomes the largest. I guess it is notable that C is a k minus 1 by n matrix. You might be onto it, Arad. And k is the number eigenvalue that you have. Quadratic form equals form squared. True. Okay. You can kill k minus 1 eigenvectors that way. Yeah. I think maybe I'm confused because we express it in a different way where we talked about, I think we achieved a similar thing in class. We just only had the maximum, but we added constraints to that maximum. And that's how we did it in my class. But I think this achieves a similar thing, maybe in a more compact way. You understood a fair share of it in the book's explanation. You just don't see how you could take this principle and actually apply it to a given matrix. Yeah, that's what I'm working towards too. I know it's your actual question. Hey, Dessen. Actually, With any vector, apply the matrix repeatedly. Get better and better approximations, or the each step to avoid floating point errors. Hey, Kunden, if I'm saying that right? Right? Okay, cool. So actually apply it to a given matrix. Do you know that would couldn't that converge to any eigenvalue with a positive, or any eigenvector with a positive eigenvalue? Or would it always converge to the largest eigenvalue? Maybe negative or positive isn't important. Hmm. Uh, Catter, I just got a master's in applied math. Bridge to the largest one in absolute value unless the initial vector is exactly orthogonal to it. Okay, fair enough. The book states the geometrical idea of this characterization is as follows. For any non-trivial matrix C, the constraint Cx minus 0 corresponds, or Cx equals 0 corresponds to the requirement that x lie on some n minus k plus 1 dimensional hyperplane in Rn. We find lambda sub k by first maximizing qx with x equals 1 on the hyperplane, and we vary the hyperplane until this maximum is as small as possible. I think that's what that's more or less the conclusion that we've collectively come to. That the matrix C just kind of, it takes care of the requirement to get the kth eigenvalue. Because the process without it just always gives you the maximum one. So if you want to get the kth one, you should take out the k minus 1 eigenvalues before it. But yeah, the maximizing q of x part in varying the hyperplane, I'm still trying to figure out. That looks like ancient forbidden text from some magic series. Yeah, this is like functional analysis stuff that I've barely scratched the surface of enough to get through a class. Is it the soup norm? Is it the max? Dessen, I guess because you got here late, right? We're talking about the Courant minimax principle. And this is the statement here. It's a process, or it gets you the kth eigenvalue for a real symmetric matrix. And Breskels is asking, how do you use this principle to actually numerically calculate in eigenvalue. But I guess Arata's given the best idea, or at least a better idea than anything I could think of so far. I was kind of choosing a more or less random vector x to start with and plugging it in and then plugging that result back in and just kind of iterating that a bunch of times. Achieving the minimum will be the span of the first n minus k lowest eigenvectors. Can't make anything about it. An ellipse or ellipsoid in low dimensions. I guess I haven't quite worked that part out either. It's kind of interesting that it's equal to 0, like c times x. So I'm thinking about like null spaces and stuff, but I don't know if that's I'm actually like coming up with anything because of that. Hmm. Want to test out with a symmetric diagonal matrix? I guess we could. Jacobi iterations for all the eigenvalues at once. Yeah, I'm sure there's probably a better numerical way to get the eigenvalues, but I think this is a question like Bressel was asking to try to understand the principle better than trying to come up with like a new numerical method that will be somehow better than existing ones. It's like I could think of how to, or like I think it'd be pretty quick to implement the maximum part. I have no idea how you would minimize numerically over a matrix, though. That seems kind of difficult. But we could get like the largest eigenvalue, not worry about the kth eigenvalue. I don't know if that'd even be helpful for Rascals to see, though. Um, Need to revise linear algebra again? Good luck. it's a good topic. Derivative of the matrix and set it to 0? I mean, probably in a sense you can. Explanation I got from my professor was in essence it allows us to approximate eigenvalues for large matrices by an algebraic equation which is easier to solve. These Lagrange multipliers to minimize. That's right. I'm looking back at my notes again. I really thought I wrote down the actual words like minimax somewhere. Oh, I did. I found it. Hmm. I'm looking through my notes trying to see if I can get a clue on like how you'd actually implement this. I don't know. We didn't really go that direction though. I don't know. I'm getting kind of close to just saying that I don't know. This is a really interesting question that I wish I could answer. But I've only been introduced to this stuff and I don't really understand it deeply at all. It's like the principle of least action. Oh, for Lagrange multipliers? Do you get it for the case k equals 1? Uh, I mean, I sort of intuitively get what the thing is saying, Leo. The actual question is like, how do you make a numerical algorithm out of this? Because it should be possible. Yeah, I understand it for like when the minimum isn't involved. Yeah, I think it's important to have the magnitude of the vectors to be some constant if you want to make this claim that it goes to a particular eigenvalue, but the actual constant it is. Yeah, I think Leo was saying it well. So if you're comparing vectors with different magnitudes, you're not assured you're going to get the actual eigenvalue out, right? Go up to infinity. Oh, yeah, that's fair enough. Okay, I'll try one last thing, which is to look for in Google Scholar. I wonder if someone has done this before and made a paper out of it. This is related to election theory or like voting theory. What the hell? If you listen to a good one, you have to divide by b squared since b squared equals 1. This question. The question is, how do you actually do the minimax, Leo? Because, like, even if I don't understand the minimax principle that well, Bresco's at least has a decent understanding of it, just not like how do you actually do it. It was converged to the richest contender. Yeah, Destin, that's what the Wikipedia page says exactly down here, which is kind of cool. So yeah, I think I'm gonna give up on trying to explain this. Um, but if Leo or anyone else wants to try to come up with something, please do. Um, yeah, I think I'm probably gonna just move on. So yeah, again, sorry, but I guess this one's beyond me. Yeah, it means that I hate you personally. Exactly that. Okay, if anyone else has a question they want to ask, please do. Um, Otherwise, I guess it's going to be puzzle time again. Yeah, maybe Zach would. He's always done functional analysis, and I haven't done functional analysis aside from like barely a taste of it to do PDEs. So you just have a better chance. Yeah, from the Sweet Life of Zach and Cody, exactly that. No, Zach is a streamer who you should watch, but he's only on Twitch. E to the 2i pi. Just and by yeah, if you have a question, please tell me. That doesn't mean it'll definitely be a piece of cake for me. I've struggled with all sorts of questions. And until I see it in chat, I'm gonna pull up a puzzle. Where were we? I think we're on 32. It is easy to arrange 16 checkers in 10 rows of 4. Harder to arrange 9 checkers in 6 rows of 3. Do both. I doesn't know it's my professor is in town Monday. If he doesn't know I'm skipping it, yeah, fair enough. Puzzle the gateway drug to the harder stuff. I don't know how to read that. Just invite. What are the ones? Let me. Cotangent A minus cosine A. And also, what's the question? Like, what am I doing with this? So, and this 1 times cotangent A? That's what I don't understand. I see someone posted an integral in the Discord too. That looks terrible though. Yeah, I think something must have gotten mangled because like these are just all canceling each other. This is the integral from a different person that was posted in Discord. Maybe log identities can clean this up though. I don't know. I'm afraid this is a competition integral. Wait, oh no, you don't have log identities for log times a log, do you? No. Do you have to do that by hand? And by? A competition question? Oh, I probably can't do it then, Nihal. I don't really know competition integrals. Those aren't clean angles to work with, so I hope you can use a calculator. Oh, maybe... Oh, we're supposed to use identities? Time was 5 minutes. A guy destroyed it in 2 minutes and 30? What the hell? Okay, so... Yeah, Fembox, I see what you're seeing for part 2. We can definitely do part 2. It's like the right side of a trig identity. Let me pull it up. So for number 2, I would use this trig identity here. Okay, so you know the answer for 2 then? Okay. It'll be sine of what, 90, so that's 1. Sounds like you already know the answer there. For part 2, Or sorry, part one. Yeah, I guess there are some assigned identities. Some to product. I guess that's our best shot. These bad boys. Okay, so the numerator, a beta integral? I don't know what those are. A numerator becomes 2 sine. Ugh. That plus that. I'm not doing 0, 1, 9, 4. 490 divided by 2. It's 2, 4, 5 degrees. Why did I do what again? You never seen these? They're pretty vague. You don't usually have to use them. Oh, my hair? It's just easier to manage. I don't know. We could do that, Desson. I did not get lice. I just I don't feel like going to the barber. Basically. Um yeah, I'm trying to remember how you can prove these. Bye nerd? Okay, bye. Meow. You probably use them with you probably prove them with some indifference identities. Yeah, that's definitely it. So actually, okay, if you're not allowed to use those, okay, we're not gonna do Euler's formula though when if it's just in a trig class. You definitely could though. Um, I think you just be clever with your sum and difference identities if you want to show them. Uh, so if we want sine plus sine. Actually, how? No, I thought maybe it's not as simple as I thought. Yeah, that's what it seems like. You also it's not just these. The answer is supposed to be sine of 263, apparently. Really? You can? Nihal? See, I remember those identities, like sine of 90 degrees. minus theta, I guess, yeah, is equal to cosine theta. So what does this cosine of 217 become? Write the numerator first. Cosine of 217 is equal to sine of 90 minus 217. Oh, wait. Oh, there's a typo. That's okay. I misunderstood what you were saying. This is sine squared of 63 degrees. I assume that's true for everything then. That changes the problem completely. Oh my god. Okay. Wow, you remember solving this exact problem? That's crazy. Nihal. Preferred it the wrong way? This feels way more achievable. Well, I guess, okay, we can still use the identities that if we convert everything into signs. Sorry, I thought the final answer was going to be sine squared of 63 or something. Sine squared of... Isn't that 73 though? Oh, I see the point. Okay, so you don't convert it all to sines. You convert just one or the other. I was trying to get a cancellation with like up top and bottom. Yeah, I see now, Nihal. Thank you. We'll convert that into cosine. Does become 63, right? I'm just okay, yeah. Oh my god. So you just get 1 divided by 1 is 1. Yeah, that is a lot less exciting. It's a lot easier though. I'm glad we didn't have to use the sum to product formula twice. Okay, so just and by I hope that makes sense. Let me know. With this integral that Neil posted, I doubt we can do it. It's I'm sure I'm kind of with anything that might be useful there though. Like I don't think integration by parts helps. I don't imagine a U sub helps. Squares, I thought trig was triangle. True. What are triangles if not half a square though? Do trig with can you? I didn't know that. Like is a hyperbola a closed figure? You can do trig with those. Yeah, if you want, Nihal. Check out the beta integral. Okay. Something that could work, Fembox. You can think about that. I just want to see what the beta... Okay, I can see what you mean. It's like a beta integral. Uh, but we have logs instead. So I can see why it would remind you of that. Let's scroll through it and see if there happens to be an exact match. King's rule? I know of King's rule. Usually if King's rule is involved, I just don't do it. We can look up what King's rule is, though. You can continued fractions that thing? What the hell? What? You can get a continued fraction for this integral. That's kind of mind-blowing. I would never have expected that. Okay, anyway, I don't see the exact thing here. Okay, yeah, the answer... Oh, zetas? Bruh. Okay. Oh, wait, I said I was going to look up King's rule. Uh... Math. Does that have a Wikipedia page? Maybe not. An analytical number theorist? Uh... I'd like to become a lot of things. That I wouldn't mind becoming an analytical number theorist, I guess, but that's not high up on my list. Just tell me what King's property is, please. I don't care. This is like when you try to look up a recipe and there's a frickin' essay for the actual recipe. Oh, that was King's property that I was just looking at. I don't use the AI thing, though. Dirty integration tricks you need up your sleeve. The King property. Okay. It seems like something to try. So how do we apply King's property here? A plus B minus X. So, wait. If f of x is log squared 1 minus x, log squared 1 plus x, we want f of 1 minus x. One minus x. I can't do that in my head, apparently. That becomes log squared. I mean, that, wait. Never mind, that becomes an x. I don't know if that's forward progress or not. I couldn't tell you. Find all positive integers x, y, z, so x squared plus y squared equals 2x, y, z. I don't know how to do that, Yanro. I'm sorry. Can you make a sphere into a cube? Oh, okay. Um, if we kept doing King's Rule, I don't think we would get any improvements. I don't think. I think I might just cycle back to the original problem, actually. Yeah, I don't see anything to do with this integral. uh, Breskel said post was probably an equally nasty integral too. E to the minus pi over 2 tan x. It's not that bad. It's your favorite integral of all time. It reminds me of the type of integral that I would look at in my asymptotic analysis class. When you have e to the power of a function and you need to integrate it. But I don't think we're doing asymptotics for this. We're doing an actual answer. Oh, Feynman? Ugh, okay. I'm glad you told me before I tried typical calculus stuff. I guess I was looking for complex variable stuff. Yeah, I much prefer the person at the start stream who asked me to explain what is integration. That type of question I can actually handle. Okay, so we're going to define I of alpha equal to 0 to pi over 2. Oh, I assume this pi over 2 stays the same though, right? E to the minus alpha tan x. Okay. And then take two partial derivatives. Assume with respect to alpha. Oh yeah, because Feynman is differentiation underneath the integral. Yeah. With respect to alpha. So we just get tan squared x e to the minus alpha tan x. Oh wait, yeah. A contour. God. Those take so long. Okay, what do we do now? Is this integral somehow easier to evaluate? Derivative of tangent is secant squared. Yeah, because this is like 1 minus secant squared or something. Do I still have my trig thing open? Secant squared minus 1. Oh, okay, I can see the ODE that comes out of this. One way of solving? I mean, this is me being spoon-fed the answer, basically, but thank you. Sam Gaming. And Tet, welcome in too. Okay, so We're going to split this up into two different integrals. The first one with secant squared, we can do a u sub, I assume. The second one is just our original integrand. So I'm going to call it I of alpha again. And so this will become an ODE in alpha, I guess. This one, we need to do a u sub, I would think. U equals tan x. Du is secant squared x dx. Yeah, like the requirements to interchange differentials and integrals are really relaxed. It's not, you don't need much. 0 to pi over 2. Oh, when x equals 0, tangent is 0. When x equals pi over 2, tangent pi over 2. Oh, that's infinity, isn't it? I guess that's okay. Am I right? Yeah, I think I'm right. E to the minus alpha u du. And we can integrate that. Oh, yeah, that's fine. Everything is legal if you don't get caught. True. Never catch me doing this without contours or some shenanigans. I don't know how you would set up the contour part. Like when the bounds are finite, it's really annoying. And yeah, the integrand itself is also really tricky. Number 32, low-key beating my ass. Number theory has a way of doing that. I don't blame you. Minus 1 over alpha. Oh wait, was I? Okay, yeah. Okay. No, never mind. E to the minus alpha u 0 to infinity. The infinity part drops off. The 0 part becomes 1. That's the lower bound, so that minus turns into a plus, so we just get 1 over alpha. A. Okay. Can I solve the Riemann hypothesis? If I could, I would. Yonro. If I could, I would. Then it goes like exp minus ay over 1 plus y squared after change of variables. Oh! Right angle contour might work. Yeah, I bet Feynman is easier here. Nihal, that might work. I wasn't sure where to go after that, though. I mentally thought about it for a little bit, but... Number theory just a friend that you haven't met yet? I feel like I have met number theory a little bit, though. I don't know. It's possible I will like analytic number theory or something, but I don't know. Contour integral, something like, yeah, that's exactly an example of a contour integral. If you know line integrals in multivariable calculus, it's very similar, just in the complex plane instead of the xy plane. And I can tell you right now that integral is 0. Don't even have to think about it, because the unit circle is a closed contour, so it ends where it begins. And e to the z has no poles. It's an entire function, except at infinity, but we don't count that. And so when you have a closed contour and you're not enclosing any poles, I just thought of a question about that, actually. But the answer to the integral is 0. Okay, yeah. The question I just thought of is, in complex analysis, you sometimes do reverse the contour and think of it as enclosing the outside. That integral would actually not be 0. And that's okay. Okay, yeah. Complex integrals greater than real integrals? I think so, too. But yeah, and Max, we talk about like what contour integral actually means too. I just want to get through this problem first because I think we're in the home stretch. At least I hope we are. That's a second order ODE, non-homogeneous, but the non-homogeneous part is just a constant. Wait, no, it's not a constant. Ah, it's our variable. How do you deal with that? I assume we want undetermined coefficients. What do you guess? Paul, do you deal with this? Oh, okay. So we or undetermined? I still don't know what to guess for undetermined. That's usually my first choice for second order. But when it's 1 over x, I don't know. Is there even a built-in guess? Okay, let's do variation of parameters. So it's just a formula. It's an annoying formula, but it's just a formula. Okay. Remember how to get the Wronskian. Two right skians or two wrong skians don't make a right skian. The Wronskian, is it the first derivative or second derivatives? Oh, that's what the Wronskian is. Okay. Wait, did my thing freeze? No, it didn't. Never mind, I'm just dumb. Okay. Oh, we need the homogeneous solution first, Doi. The homogeneous solution is C1 sine alpha plus C2 cosine alpha. Yes. So sine is y1, cosine is y2. Wronskian. Sine alpha, cosine alpha, derivatives. Cosine alpha minus sine alpha. Minus sine squared alpha minus cosine squared alpha. Oh, hey, look at that. Minus 1. And then the particular minus y1, so minus sine alpha integral. Y2 is cosine alpha, g of t is the inhomogeneous part. Oh. You hate to see that. Oh, okay, we're just gonna call them special functions. Okay. That makes life a lot easier. So I'll say like that. That's just, and we don't even have bounds. I don't think. I don't remember if we can find bounds. Which country? Question anyone? I don't know what you're asking, Render. Okay, so since we get to call them special functions, we get sine of alpha. I guess we'll call it ci. Oh, it's from the original one? Okay. Yeah, I was wondering, like, if the bounds are, like, over a period, we could probably say it's 0, but... Yeah, I guess we have, we're gonna, well, yeah. We're gonna plug in alpha equals 2, but I don't... I don't know what else, like, to think about there. So Actually, how do we get the... How do we solve for C1 and C2? Enable? I don't know. I don't know the source of the question. The original question is this thing right here, though. Enough it goes to 0 and infinity, you do. So when alpha is 0, we're integrating 1, which is pi over 2. Okay, haha. Yeah, that makes sense. Okay. So right here, I could have said, we know alpha, or I of 0 is pi over 2. I have infinity, great notation, is 0. Okay, that makes sense. So we use that to determine C1 and C2, and then we're home free. Well, I mean, this might not be a walk in the park either, but let's see what we get. The sign goes away. We get just C2 minus SI of 0, whatever that is. Is that a... Ooh. Oh. I needed a dummy variable here. Or... Yeah. SI of 0 is 0? Okay. Yeah, because it's actually the integral from 0 to alpha, and this is a dummy variable, right? I should have paid more attention to that. Okay, so C2 is pi over 2. I have infinity because infinity is a number. 0. I don't like that. Or what a sign of infinity? I guess, could that force C1 to be 0 then? Because it has to converge? Would the rest of this agree? Because if Ci and Si are both 0, I think we're okay. I don't know if we can justify that though. Got some corners since the pi over 2 term sine of alpha disappears. Oh, haha. Well, wait. Sine of pi over 2 is 1. That one doesn't go away. Well, I feel like we have a problem though, because I just try to plug in I have pi over 2. Like, the C2 goes away, but that's the one that we do know. Hmm. No, I think we need to know the coefficient of sine. Maybe I made a mistake. Yeah, no worries. I'm still thinking about Max's question about what is a contour integral. I don't know if Max is still here, but I'll pull my textbook. I forget if you define it in terms like a sum of real integrals. Like a lot of things are. Hey, Harsh. So, I'll wait to hear back from Breskles. For contour integrals, you can always split up a complex valued function as the sum of a real part and a complex part. And so, not thinking about contours at first, you can still do the integral from a to b of a complex function by splitting it up into the real part and imaginary part, and then your normal integral stuff for real functions applies, because the I can come out front. Oh yeah, good luck, Harsh. Oh right, and then once you know this, you can always parameterize your curves to make it a contour in the entire complex plane, rather than a straight line between 2 points. And that's all. Yeah, and that's all a contour integral actually is. Yeah, this is come back to note. So as long as you understand what a line integral is, a lot of the same stuff kind of applies. So if I think for line integral, for this to be true, the function has to be conservative. I kind of wonder why, but in the complex world, it just needs to be analytic, which just for our purposes means differentiable. So the function has to be continuous in the domain also, but yeah. It doesn't have analytic number theory, hence not a good complex book. True. In 2026, it's easy to look back at 2021 and say NFTs were stupid. In all fairness, it was pretty easy to do as well back then. I mean, that's true with a lot of things, Syntax. People were laughing at Bitcoin for the longest time too, and then it suddenly became a serious thing. And then when it crashed, people went back to saying how stupid it is, and then it came back. Like it doesn't mean it's a great idea for everyone to get involved in them. I mean, like you should know what you're doing if you do get involved in them, but I don't think it's ever been stupid to get involved. So I prefer algebra. At least I know what I'm doing. Everything seems more concrete. That's my problem with algebra. I don't know what I'm doing, and nothing seems concrete. So yeah, if Max pops back up in chat, we can talk about contour integrals again. I didn't realize this would take me as long as it would. I do wonder if I made a mistake here. Oh, wait, so I don't know if you heard that, Max. I was just talking about what a contour integral is. And I can say it again if you didn't catch it. Yeah, that's Breskel said that that's allowed for this problem. If you want to integrate sine of x over x and cosine of x over x, be my guest. And so if you just lurk in max, I'll just leave it be and you can tell me when you're ready. Hmm. Is finance much more convenient to have the uh specific value of CI? Yeah, that's good enough for me at least. Do I know why variation parameters works? I don't. I theoretically I was supposed to have learned the proof during my asymptotic analysis class. I wasn't really paying attention though, so no, I don't know why it works. It's just CI pi over 2? Okay. I wonder why I must have done something slightly wrong. Um yeah, so Max, it relies heavily on a line integral in multivariable calculus. Um so first off, when you have a complex valued function, you can split up into real part and imaginary part, which is the part that you said that you heard. Or I unless you meant the part after this, but and so knowing that, you can define complex integration along a straight line between 2 points, just like this, where you split up your integral into a real part and imaginary part, and then you have 2 real integrals that you can evaluate and get an answer for that. And so you can use kind of like this form to get your normal uh, integration rules for real functions like FTOC. And then you can extend this to be any curve with the magic of parameterization. So instead of straight lines, you can just parameterize a curve. Z is a function of t. And that gives you kind of whatever you want. If you actually do the change of variables, you get this. And so that gives you any contour starting and ending at a particular point. And for multivariable calculus, you might know, is it here? Where is it? in multivariable calculus, there's a certain class of integrals that the path doesn't matter for. It only matters where you start and where you end. I think for conservative vector fields. I can't find where Paul says it, annoyingly. But a similar thing exists in contour integrals, which is why I knew the answer to your question. Where if your function is analytic, meaning just differentiable, or at least the result of the integrals is analytic and the integrand is continuous, then your path doesn't matter. It's just the result of the integral of the endpoint minus the beginning point. And so for the unit circle, you're starting and ending at the same point. So this theorem applies, and you just get 0. So yeah, the short answer is a contour integral is, it's really just a two real integrals added together with an imaginary like unit. The magic is though that you get all these extra theorems that are really helpful. Yeah, no worries. It's really cool. Complex analysis. Highly recommend it. CI pi over 2. Yeah, I definitely did something wrong then. Because my CI function would disappear. So I think I swapped two functions at some point. I don't know where. Oh, really? Hey, Floppy. It made sense to me. Use mixed conditions I and I prime. Okay. See if we can fix it. If this one did post a contour integral that we could try. I prime, I assume 0 is still the convenient thing to plug in. Oh wait, you're so you're not using 0, you're using infinity for both of these. Oh, okay, fair. How do we think about I have infinity? I don't know how to deal with infinity for these though. Things are a little too periodic for me. Robert, so we just need one PC that gives us C1. Well, yeah, so we would want like pi over 2 or 3 pi over 2 or something, I would think, but I don't know. I guess pi over 2 is the question, so it can't be that. I don't know. We're so close, but no cigar. You remember now? Okay. Skip a lot of my notes. That's what it causes. Yeah, I've been there. See, I have infinity is 0. Really? I wouldn't have expected that. Cosine of x over x is different than sine x over x, though, so... Well, okay, I still don't know what to do with any of these other terms, though. I don't know what to do with sine of alpha, cosine of alpha, or that. The integral converges to 0. Can determine our C. Yeah, I don't know how. I don't want to see what it looks like in a graph, though. Cosine of x over x. Oh, that is so much different. Wow. That makes sense. I almost think this graph is cooler than sine x over x. No pep. I'm just gonna say no pep or nope. I don't know. I don't know chemistry. Actual education though does. The first person or the second person in that list. I need to add Leo into that list. But yeah, actual education can help with chemistry. Maybe you'll know more about contour integrals in 2 years. You plan on studying math next semester. Higher analysis optional. Recommended starting the 4th semester. Ooh. Yeah, if you can do it, I think you should. Graph makes you feel things. Hopefully good things. I think this graph is pretty fun. Bad things. Nah, this is great. It feels wrong. 2 used to 1 over x. That's fair. No, Edgend? Probably saying that wrong. Thank you for the follow. Such a sexy cosine. Look at those curves. You like it nonetheless? Okay. You don't have to like it, but the original BC works too. Then you don't integral a few times different ways. I can't make anything involving infinity work. Can I do it with so? What did we say I of 0 was? I of 0 is pi over 2? That at least seemed like something. Can I do like I of 0 and I prime of 0? No, I prime of 0 diverges. Never mind. I don't know what to do. Yep, next semester won't be too stressful since you still want to continue computer science. Oh, yeah, that could be a lot. By some reason, this reminds me of those bicycles made for non-flat floor. Like a mountain bike? Yeah, links are turned on. If you square it, does that clean up the sine plus cosine a little? I don't think so, Arcane, because we have the constants in front. Or, unless you're talking about these, I don't think no, I don't think that'll help either. A bike with square wheels? Never heard of that. Oh, these, wow. Math Museum square bicycle wheels. Oh, that's what you mean by non-flat. The wheels aren't even the same size. Look at that bike. Both the bikes, the wheels are. Oh, because yeah, you're going in circles. Huh. They're high fiving each time they go by each other. Never seen that before. Okay, I don't know how to get a second useful boundary condition. I can't make anything with infinity work, and I can't make I prime of 0 work. And I don't know what other. Like, I don't think negative infinity is any more helpful. Apparently, there's some math museum out there that has square wheel bicycles. I prime of infinity should work. Let's see. I mean, I guess I didn't take the derivative of this. We should see how that looks. What does this become? C1 cosine alpha pi over 2 sine alpha. We have an annoying product rule. Normal theorem of calculus. Minus, well, minus down here. Minus sine alpha, si alpha, plus cosine alpha, sine alpha over alpha. Okay. I feel like I flipped the sign. Hopefully I didn't. I don't, I think I'm okay. Uh, I prime of infinity. Well, okay. The good news is these go to 0 as alpha go to infinity. Um, I think we just want C1 equals 0. If we can justify that, I think we're okay. These integrals... Can't imagine that they're 0, though. Are they? Or did we say that earlier? I have the actual solution in your notes. Cosine infinity term cancels. For I of infinity makes C0. I don't see how. I can believe you. um, we have a pi over 2 cosine of infinity. Would we need SI of infinity to be equal to pi over 2? That'd be weird if that's true. S of infinity gives 0 if you factor cosine infinity. Oh. Okay. S of infinity is 0. Hmm. Um. Okay, so that is 0. So we get a just pi over 2 cosine infinity. Did we say anything about ci of infinity? I forget. You got to when we first got 1c to be pi over 2, bc at 0, plug in infinity. Yeah, that's what I'm trying to do right now. C of infinity is 0. Okay, well that gets us the answer that we want, I guess. Well, ooh. Wait. So, okay, C of infinity is 0. I'll just go with it. But I just realized I do have a question about the first thing you said. You have pi over 2 minus si of infinity times cosine infinity. You said si of infinity is 0. Or... Okay, no, you're saying it's equal to pi over 2 and these two things can't cancel. And then if we have C1 sine... Oh, I wrote alpha, I meant to write infinity. Okay, okay. That's what it needs to hear then. Okay, so this means C1 must equal 0 because there's no way sine of infinity is going to equal 0. Okay. So we can finally get the actual answer we want, which is I of pi over 2. This term is 0. That's pi over 2 times 1. So pi over 2. Wait, sorry. Cosine of pi over 2 is 0. So that's also 0. So 0 plus 0 plus sine of pi over 2 is 1. So we get ci of pi over 2. Cosine of pi over 2 is 0. Okay, there we go. I probably should have just Googled those functions. What's the name of it? Dirichlet integral? Okay. Wow, that is kind of crazy. I would not expect that to be pi over 2. Hey, Euphoic, if you still want to ask your question, please do. I have time now. Question quick before Mr. B strikes again. Oh, wait, not split view. What the hell? No, this is not what I wanted. I was looking for like cosine of x over x. I don't know though. You've given it to like everyone? Yeah, I mean, Feynman is always exciting when it comes up in an integral. Sine and cosine integrals? Okay. This is... Well... Maybe this one. Hey, there we go. Oh, wait, you know what? Just out of curiosity, I don't talk about this enough on stream. I think it's a really cool website. Where is it? DLMF. The Digital Library of Mathematical Functions. I bet these functions are on there somewhere. Here. I guess definitions and interrelations. Here we go. Oh, they do 1 minus cosine t, so it converges. That's fair enough. Oh wait, no, that's sin. Oh my god, sin. I hate that. Uh, they do have CI. They define it as minus though. Interesting. So yeah, those are the values at infinity. And so they just have a bunch of like helpful things calculated for commonly used weird functions like these. It's like Euphoic is putting a question. I assume it's going to go on. Lemay functions. Integrals with coalescing saddles? That sounds cool. I don't know what that means. Catastrophes and canonical integrals. The hell? Cuspoid catastrophe with codimension k. Try saying that 10 times fast. What is a fold catastrophe? Or swallowtail catastrophe? Okay, I'm going to Google this. Catastrophe math. Catastrophe theory. It's a branch of bifurcation theory and study of dynamical systems. Particular special case of more general singularity theory in geometry. That's kind of cool. Oh, it shows in dark mode? It doesn't seem like a very modern website. Yeah. Unfortunately. And you folks, I'm waiting to see the rest of your question. I only see the first line. Well, I don't think that's a question, you folk. I don't know what you want me to do with that. Essentials may be arising from small changes in circumstances, analyzing how the qualitative nature of equation solution depends on the parameters that appear in the equation. Orbital time magnitude of a landslide. That's kind of cool. I've never heard of catastrophe theory before. Hmm. Uh, okay, you folk. Let me see if I can figure out what you're writing there. you have f of x is equal to ln 1 plus x minus 1. You have two x's here. I don't, it's like you have x there. I assume there's only one x, or I need you to tell me if I'm writing down your question correctly. If this is the question, I think I know how to do it, but I don't know if I've written it what you've down said correctly. Oh, there's a fraction. Okay. Um, and one more question. Is the squared in parentheses on the outside like I've written here? Or is it f of x over x squared like that? mx, no, this is a, a writing tablet with a PC. The program is called Journal++. Fraction is on only under x. Oh. Like that for f of x. Okay. Okay, cool. So we're on the same page for f of x. How about, what are we maximizing? No worries, mx topper. Square is only on x. Okay, cool. So what's the second one here? Okay, I think I know what to do then. So if we want to find f of x, or the maximum of f of x over x squared, we take our original function, divide it through by x squared. So ln 1 plus x over x squared minus, this x up top will cancel with one of the x's. We get x times 1 plus x. So this is a function that we're really interested in. I'm going to name it g of x. And so g of x is the thing that we want to maximize, and we can do our normal kind of calculus rules for maximizing things on g. So let's start by taking the first derivative. This is a quotient rule. So high d low minus low d high for x to the fourth minus, we could do that as a quotient rule too. Is that the easiest thing? I guess I'm going to do a quotient rule. It's really not necessary, but I'll do it. Low d high, but that's 0, minus high, which is 1, D low, which is a product rule. Which is probably why I shouldn't have done this, but oh well. You did one mistake. Oh, okay. If you got it from here, then I'll leave it be. Thank you, $10. Yeah, as soon as I started to actually write the quotient rule, I kind of regretted not doing it the way that you said breasticles. But I guess my mind was on the quotient rule already. Okay, I don't want to stream for much longer. But we could at least look at the contour integral that Desmond posted, unless someone else has a question. Huh. This is always an odd function. That's an important observation. So the integral from 0 to infinity is a half. Wait, that's for even functions. Sorry, wait, no. Oh my god, oh my god. If n is even, we can do that. If n is not even, it gets harder. MX Topper, this is just a question that someone gave me. I don't know what book it comes from. Because this function could be even or odd. I just did it stupid there. If n is even, the function is even. If n is odd, the function is odd. Well, I assume the even case, like, do we want to do cases? The even case is probably just easier. Does still have my complex analysis book open? I think when it's a polynomial like this, you do like a pizza slice contour. Depending on the degree of the polynomial. Is it? Oh, it might be down in residue calculus. Ludwig, unfortunately, yeah, there's a lot of memorization. Here's our pizza. It's a very big pizza slice. Okay, so I did remember correctly. So I think we do want even and odd cases, unfortunately. So that's normally a good first step with contour integrals. If it's an even function from 0 to infinity, it's easier to do the integral from minus infinity to plus infinity. Because you can then just use Jordan's lemma. And so I'm just going to use shorthand. The integral over the semicircle of z to the n over 1 plus z to the 2n dz is equal to the integral from minus infinity to infinity x to the n over 1 plus x to the 2n dx plus the integral over the arc, which Jordan's lemma gives us. Remember how that works. I think it's early on in this chapter. Oh. But wait, no, this does not work for n equals 2. Or, oh wait, no, it does work for n equals 2. Because that's x squared, that's x to the 4th. So the degree difference is met. So it's just 0, actually. That's nice. Whenever it is equal to 2 here, even function is confirmed. Yeah. So this bad boy is equal to 0. This bad boy we can figure out using residues. How many poles do we have? With imaginary part positive. N is even. So we don't have to worry about -1. Well, actually, yeah, we never have to worry about -1. So we don't have to worry about any discontinuities on the contour, or poles on the contour, thankfully. It's a roots of unity thing. I guess we're interested in solving this equation here. Oh god, Vanch. I'm really sorry that is, I don't think I can do that question. Yeah, I'm sorry, that looks like something crazy. I don't know how to do that. E to the I pi, Zach's evil twin. Two n theta is equal to e to the I pi. 2n theta equals pi. Oop, 2k pi. Oop. So theta is pi over 2n plus k pi over n. where k equals 0 up to n minus 1. Or 2n minus 1. We only want the first half of these, though, don't we? If n is even, 2n minus 1 is an odd number. Is that significant? Hmm. Oh wait, 2n minus 1 is an odd number. We're counting from 0, so we have an even... Okay, there we go. I was getting concerned that we had an odd number of poles, but we don't because we're counting from 0. How are we going to do the summation, though? We have to hope we get a known series out of it. So the poles that we're actually enclosing that we're interested in correspond to k equals... Wait. If k equals 0... I think we're okay. Are we okay? N is a number greater than or equal to 2. Yeah, I mean it's almost roots of unity, but it's not quite. It's like anti-roots of unity. And the n constant is throwing me off. We want all the k's up until this quantity becomes greater than pi, basically. Shouldn't be equal to pi. Let's say I hope not. 1 plus 2k over 2n less than or equal to 1. 1 plus 2k less than or equal to 2n. I guess we're solving this for k. K is less than or equal to n minus a half? That doesn't make any sense. Does it make sense? It might make sense. We have 2n total things here. So maybe that does make sense. Does that mean we want 0 through n? No. 0 through n minus 1. Okay. So we have to sum up all these residues, multiply by 2 pi I. 2 pi I times the sum. Wait, what is the residue? I need to... I forget how you calculate these residues again. I know it's the -1 coefficient in a Laurent series, but there's you never want to use that if you can help it. Partial fractions. We're not doing partial fractions for this. That's just not going to happen. Should I just use the formula? This annoying thing? It's not that bad for, Wait, are these all simple poles? They should be. My gut is telling me they should be simple poles. Uh, yeah, Vanch, that last sentence, I have no idea what that means. I feel like you're doing a type of math that I don't know how to do, though. I'm sorry. Oh, this is the one that I want. I remember this formula now. When are you allowed? This is only for simple poles, I think. I'm just gonna assume they're simple poles. It's really lame if they're higher order poles. How long does it take to become really good at math for someone who's just starting? Uh, it depends how you define really good. I have a master's in applied math, and I don't think I'm really good at math. Um, so I think it's a matter of setting a goal for yourself and trying to find a path to get you to that goal, and then you can start to think about like how long that should take. But I don't know what it means to be really good at math. To be honest, like what that actually means. As Sublock says, yeah, you can. There's not much to do besides just studying every day. As lame as that answer is. I live in America. I live in Washington State. We have z to the n over z to the 2n. This is this is only half the problem, by the way. Take the derivative of the bottom. I'm kind of tempted to just bail on this problem because I'm getting tired. Like I feel like I know how to do it. It's just a matter of like plugging through it. Okay, z is e to the I theta because r equals 1. And theta pi over 2n is k pi over n. over 1 plus 2n to the n e to the I pi over 2n plus k pi over n to the 2n minus 1. Okay, if this summation doesn't clean up into something like a geometric series that we can actually work with, I don't know what to do. I don't know if I'll call myself a great mathematician, but thank you. MX Topper. Hello, Nick Generation. I can try. What's the question? The denominator of this is really lame. It doesn't clean up at all. Oh, wait. Never mind. Yeah, I don't know how to deal with this summation. And if I can't deal with it, then I'm stuck on the problem. I mean, k is the thing that we're summing over. It's the 1 plus in the denominator that kind of ruins everything. I'm not a teacher, MX Topper. So yeah, Nick Generation, if I don't see your question in a minute or two, I'm probably just going to call it for the day because I'm getting tired. It's annoying. I feel like I made really good progress on this. I look like Albert Einstein. I don't think I do, but thank you, Cyrom. Okay, there's Nick's question. I'm sorry, Cyrom, I don't remember. Oh, wait. Oh, maybe I do remember you. So we want to prove this. You're not the first one, I don't think. Oh, I think we had a common denominator here. So I'm going to multiply this fraction on the left by 1 minus sine theta divided by itself. And a similar thing on the other fraction. I think it'll all work out after we do this. In the numerator, we get 1 minus sine theta plus 1 plus sine theta divided by 1 minus sine squared theta. Sounds good, MX Topper. And yeah, the SAT is hard. Okay, so on top, 1 plus 1 is 2. Minus sign plus sign is 0. So we just get a 2 on top. And then 1 minus sine squared is actually equal to cosine squared. Pythagorean identity. And then we're actually almost there. We seem to remember that 1 divided by cosine is secant. So 1 divided by cosine squared is just secant squared. So I'd say this is our proof here. I think the really tricky thing is knowing to do this common denominator trick. But I hope that makes sense, Nick. Let me know if you have any questions about that. Okay, you understand it? Great. I did take the SAT, yeah. I mean, when I took it as out of 2400, I got an 1860. That is going to be it for me for the day, though. I want to get some rest. So, people here on YouTube, Cyram, Nick, MX Topper, and anyone else, thank you all for being here. On Twitch, we're going to look for a raid. So, goodbye, YouTube.